Good morning, dear students. I am Dr. Srinivas Patni, Professor of Chemistry in Sri Academy, Hyderabad. So today I am going to teach IUPAC namings. IUPAC. So what is meant by IUPAC? International Union of Pure and Applied Chemistry. IUPAC means International Union of Pure and Applied Chemistry. So worldwide, all the chemists or all the scientists are given the name according to this rule. According to IUPAC, every possible organic compound should have a name and structural formula. We can also say systematic name of all organic compounds. And common names of organic compounds are called non-systematic names. So there are two types. So IUPAC names are called systematic names. Systematic naming. And one more is there non-systematic naming. So systematic name comes from where? IUPAC, according to IUPAC names. So we have given the names of systematic names according to IUPAC, whereas non-systematic names, these are called common names. We can say common names of organic compounds. So common names, we can say common names. Common names. Yesterday I have given best example. Common name is one acetylene, 2 carbon, acetylene. So that is IUPAC name is ethine. So ethine is the IUPAC name, acetylene is the common name. So there are two types of namings are there, IUPAC name and common names. IUPAC names also called as systematic naming and common names also called as non-systematic naming. So non-systematic name which are given by a source, which are given by source and states of compound in the nature. So that compound is available where? And what is the source? In the nature. So that is the difference between the systematic name and common name. So IUPAC names and common names. So systematic, non-systematic. IUPAC name, common names. Okay, it's clear. So now in IUPAC namings, there are 3 words you must remember. What are that words? They are very, very important names. They are prefixes. One is called prefixes. And second one is suffixes. Prefixes, suffixes. One more is infixes. Prefixes, what you have to remember, suffixes and infixes also you have to remember. These 3 words are very, very important so to give the IUPAC name. These are used to describe the type and position of the functional group. So different types of functional group I will explain you. So what are the functional groups are there, what are the common groups are there. So in the given compound, so if functional group is there, so what is the position and what type of functional group is there. So this will explain prefixes and suffixes and infixes. So these words to describe the types and position of the in the organic compound of the chain. We also remember other three words. You know the already hydrocarbons we discussed earlier. The three videos already I explained hydrocarbons. Alkanes, alkenes, alkynes. Hydrogen and carbon, just hydrocarbons. I explained hydrocarbons. And aromatic compounds. And aromatic compounds. And functional groups. So these words you must remember. Hydrocarbons, there are prefixes. Hydrocarbons are prefixes. And aromatic compound and functional groups are suffixes. So here hydrocarbons. And these are the suffixes, which are aromatic compounds, aromatic compounds, and other one is aromatic compound as well as functional groups. You know that functional group amines, carbonyl compounds. I will tell you later. So and functional groups. Just suffixes, okay? Suffixes. So suffixes are aromatic compounds, functional groups. Prefixes hydrocarbons. Hydrocarbons mean alkanes, alkenes, and alkynes. Hydrocarbons are already we described in the last two videos. They are alkane, alkene, and alkyne. They are prefixes. Now in suffixes there are aromatic compounds and functional groups. So best example aromatic compound, you know that benzene, and best example of functional group amine, carbonyl compounds, CO. So we will discuss later just functional group and aromatic compound or suffixes. Okay, clear now? So now see that the steps for naming an organic compounds are, what are the steps? We have to the steps. So what are the steps? The steps are important. So what are the steps are there? So before going to discuss the naming, you should have remember some data that is important. What is the data? So before, so up to now, so in that IUPAC names, the three words are important: prefixes and suffixes and infixes. Examples are prefixes hydrocarbons, suffixes are aromatic and functional groups. Okay, so now, so before going to discuss the IUPAC names, so we have some data we have to remember. The data is very, very important. So what is that data? So that data we have divided into three types. That A group, B group, and C group. So what is the data? The data are A type or A group, so B group and C group, or D, like that, A, B, C, D. So we are divided into three groups, A, B, and C. So depend upon the position of substituent. What is the substituent? What is the position is there? In a chain is there. What is the position of that substituent? Functional group or substituent, what is the position? So depend upon the position of the functional group or substituent. So we have divided A, B, and C. So what are the functional groups we have seen? The functional group always, I will tell you, I will write here, from highest to lowest priority. So functional groups. So highest to lowest. highest to lowest purity. So which functional groups comes first, which functional groups are comes least? So that is also we will have to discuss. Except the substituent within the group C, that will be we have kept in the group C, because the group C have the equivalent priority is there, all are equivalent. The group C is all A and B are the different types, but C is the equivalent priority. There is no first, there is no need in that group. So we will discuss later. So first of all, we have to see the what is the group A, what is the group B. So please note down, these are the very important, this data you have to remember. So first of all, data, we have to see the data. What is the data? Okay, it is data. So different types of groups. What are the groups are there? What are the functional groups? Functional groups. So we can say that family of group, okay? Family compound or compound. So compound is the family of compound. Of compound, okay? Family of compound. And we know that the structure of the functional group. So the structure also important. Structure. Then what is the prefix? Is it prefix? What is the name of prefix and what is the name of the suffix? So that is also important. And this is the prefix and this is the suffix. These are very important. Please remember this data. Without this data, we can't give the name. So we have to buy this. Then only automatically we will get few things compulsory. We have to remember. We have to buy it. Okay, that is most important. Few things means these are the highest to lowest period, which is the functional group, which are useful for what is the position. We can say easy. So now, first of all, the first priority, highest to lowest. So we have given the highest to lowest. So first highest priority, which functional group? That is carboxylic acid. So give the first priority, carboxylic group. Carboxylic acid, we can say group, don't say that. So acid, we can say acid, carboxylic acid, we can say carboxylic acid. Okay, not group, carboxylic group or simply carboxylic acid we can say. So what is the acid? COOH is the acid. COOH is acid. So we can give the name alkyl group. Already I told you alkyl group, the R group, alk group, we have to alk group. So alk must be there. Alk, one alk. Alk means meth, eth, prop, bute, pent, ept, ex, ept. That is the alk group. So alk group attached to the carboxy group. So what is the carboxy? That is COOH. Alk, acid. Acid function group. So this is the carboxylic group. Carboxylic group. And this is alk group. Alk group, carboxylic group. Attach this. This is so alk. So this is the structure we can say. Alk group will change depend upon the source and depend upon the nature. We can change it. So what is this name? What is the prefix? What is the prefix? Simply we can say carboxy is a prefix. Carboxy. So carboxy is the prefix. Okay. So I put another prefix. And suffix. Suffix is the oic acid or we can say carboxylic acid. So oic acid or carboxylic acid. So you have to must remember carboxylic acid or oic acid is the suffix and prefix is the carboxy, simple carboxy. So the number 1 is the carboxylic acid and number 2 is the aldehyde. Number 2 is the aldehyde, highest to lowest. So carbonyl compounds, we can say aldehyde. Carbonyl compounds there are two types, aldehyde and ketones. In that carbonyl compound, aldehyde will come first, that is aldehyde. Aldehyde. So you have to take alk group and aldehyde group. So alk is the R and CHO. Here COH. So we can say what is the prefix? It's a formyl or oxo. We can say oxo or formyl. Oxo is the prefix and al is the al. Simply al, al. Remember al, al, or we can say carbaldehyde. Carbaldehyde. So suffix al. If aldehyde is there, or carbaldehyde. Prefix is oxo or formyl. So now ketone. So ketone is the only CO group is there, that is RCOR. Two alk groups are present between the carbon. So two alk are present on carbon CO group. Okay, RCOR. So it is also same oxo. We can say prefix is the same oxo. Why I are giving the oxo name is that this is the oxo. So, but here suffix is changed. That is one. O-N-E, one. Ketone. We say ketone. One sound will come. So, this is the carboxylic acid, aldehyde, ketones. Now, the fourth one is the alcohol. You can say alcohol. So, general formula is alcohol. So, alcohol. You can say alcohol. So, alcohol means alk group is present OX. Alcohol. So, that is the reason alk group is this R. Alk group is present. And hydroxy group is attached here. Alcohol. Simple thing, no common name. Alcohol. Alk group. What is the alk group is present? Meat, eth, propylbutane. But somebody think alcohol is only ethanol. No. That is all alcohols. Either methanol or propanol or butanol or pentanol. Alcohol. So alcohol. So alcohol means ROH. What is the prefix? The prefix is only simply hydroxy group which is there. The hydroxy is the prefix. Hydroxy is prefix. And suffix is important. That is R. OLR. So here in aldehyde, ALR, this is the OLR. Alcohol. Okay. So these are the names. Please remember. And fifth one is amine. We can say amine group. Amine. So what is the amine? Alk group and amine group is there. NH2 or bond with NH2 amine group. So what is the suffix? What is the prefix? Prefix is the amino. Hydroxy. Amino. And suffix is amine. Simply amine. So have you seen carbolic acid, aldehyde, ketone, alkyl, amine. So simply suffix are very very important. Oic acid, al, one, all, amine. So these are all belongs to A group. Okay, these are all because these are very very important. So these are all A group. A group. Okay, these are. There are three types of groups are there. So the first A group is the carboxylic acid, aldehyde, ketone, alkyl, amine. So these are very very important and higher to lower. So carboxylic acid. Okay, please note down. Please note down. Okay. Now let's look group B. Group B function. So group B. So this is also higher to lower. So already group B I explained. This is a group B is already explained. So what is in the last two videos alkenes and alkynes. So there is no prefix. There is no prefix. Only suffix is there. So alkenes. So alkene. Alkene. So there is no. The structure is the structure. This is the structure. This is the structure of alkene and suffix prefix is there is no prefix. So E. Okay, E. And alkyne. So alkyne. So we have already. This is also we discussed. So triple bond. Triple bond. So it is also there is no prefix. So only suffix is there. That is ine. Ine, Y-I-N-E, ine and E. Okay, now see the group C. So group C. So what are the group C? This is also we discussed earlier in the last two videos. That is a group C is there is no. Group C is there is no suffix in this. Only prefixes. All are prefixes. Before will come. So all are prefixes. Already I have explained the alkyl group. Alkyl group. That is a R. The molar one hydrogen from methane or alk group. So that is a first of all is the alkyl. 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 Already I explained. So one, for example, remove one hydrogen from this one, so the bond will come. One hydrogen from alk group, so the bond R bond. This is called alkyl. So only alkyl. So methyl, propyl, butyl, pentyl, hexyl, eptyl, many compounds will come. Alkyl. Alkyl. So there is no suffix. No suffix. No suffix. Prefix and suffix. So no suffix, all are prefixes. So alkyl, alkyl, and next is alkoxy, alkoxy, alkoxy. So simply it is a RO, RO, alkoxy. So this is so it is alkoxy. You can say alkoxy. Alkoxy, alkoxy, and halogen, halogen, halogen. Simple, we write the X. Halogen is the X. X is equal to chlorine, fluorine, bromine, iodine, chlorine, fluorine. First of all, will come fluorine, chlorine, bromine, iodine, like that. So all halo mean the fluoro, chloro, bromo. You can say fluoro. Chloro, so mean halo. You can say halo. So fluoro, example fluoro, chloro, fluoro, chloro, bromo. And one more is there, nitro. So nitro also. So this is the NO2 group, Nitro. So simply nitro. We can say nitro. Nitro. Mean alkyl, alkoxy, halogen, nitrile, nitro, and vinyl, alkyl, phenyl also we can write down. So please note down all these things. So this is a very, very important chart. And vinyl. So what is the structure? So vinyl is the C double bond CH2. So this is called the vinyl. So we can write simply vinyl. Prefix is the vinyl. There is no suffix. Vinyl. And allyl. What is that? Allyl. Allyl. 1, 2. Allyl. So what is the functional group? Allyl means 3 carbons are there. So that is a CH2. CH3, so CH2, CH double bond CH2. So this is the allyl group. CH3, CH2. Mean you have to remove one bond. You can write here CH2 here allyl. You can write one hydrogen. Removal of one hydrogen from allyl group. So simply this is the allyl group. Bond CH2, CH double bond CH2. So this is the allyl. And phenyl. We can say right the phenyl. Phenyl. So that is the benzene group. Okay, benzene. So one bond. So this is a phenyl. Phenyl bond. This is the bond and phenyl. Phenyl. So don't think about the CH2 here. This is the bond attached to some compound. So here also attached to some compound. But here, if you like this one, so CH2, CH3, CH2. Don't think about this one in this table. So just you have to remember. So this is a bond attached to something, or attached to something. So just a bond. So phenyl, we can say phenyl. So this is the phenyl. Okay. So this is the chart. So some alkyl group, especially we have to remember methyl, ethyl, propyl, allyl, butyl, isopropyl, butyl, and secondary butyl. So we have to remember. So removal of one hydrogen from anything, isopropyl, isobutyl, or methyl, propyl. If you want, I will write the structures also. For example, methyl you know, ethyl you know, propyl you know. But isopropyl structure is isopropyl structure. Just this is the isopropyl. So this is also R group, removal of one hydrogen. So this is linked with a bond. This is the bond, isopropyl. So N-butyl. So N-butyl means simple this one. CH3, CH2, 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 CH2 bond. CH2 bond. So N-butyl. So secondary butyl mean, for example, secondary butyl CH, CH3, CH2, CH3. So this is the secondary butyl. So all are, these are also what we can say alkyl groups. And other also we can say secondary butyl, tertiary butyl, isobutyl. Tertiary butyl means 3. Okay, now some common alkyl groups. Some common alkyl groups. What are the some common alkyl groups? Common alkyl groups. So alkyl mean, for example, R is the alkyl. So removal of one hydrogen from alkanes. For example, CH4, you remove one hydrogen minus one hydrogen. So CH3. So this is called the methyl. Methyl. Now C2H6, remove one hydrogen. CH3, CH2, ethyl. Ethyl, methyl, ethyl, propyl. Propyl, CH3, CH2, H2, this is called propyl. You know these are the common, and we also see the isopropyl, isobutyl, secondary butyl. How can you write? For example, isopropyl. Propyl group means 3 carbon, 1 methyl ethyl group. So we can write that is the CH3. So this is called what? Isopropyl. Isopropyl. So this is propyl. This is isopropyl. Propyl group, isopropyl group. Butyl, CH3, CH2, CH2, 1, 2, 3, CH2. This is butyl. Butyl, secondary butyl. This is N-butyl. We can say N-butyl also. N-butyl. N-butyl. So how can you write the secondary butyl? So secondary butyl, same thing like this. Secondary butyl mean, so CH, CH3, CH2, CH mean CH, CH3, CH2, CH3. So right, this is isopropyl, this is secondary butyl. Secondary butyl. Secondary butyl. Okay? And so from butyl, we know that N-butyl, that is butyl, secondary butyl mean 1 methyl propyl. We can write 1 methyl propyl. So this is a propyl. 1, 2, 3. 1 methyl, 1 position containing the 1 methyl propyl is also called as what? Secondary butyl. So now we have to see the isobutyl. How can you write the isobutyl? How can you write the isobutyl? This is N-butyl, secondary butyl, N-butyl, secondary butyl, N-butyl, secondary butyl. Now write the isobutyl. Isobutyl. Just write the isobutyl. CH2, CH3, This is the isobutyl. See difference? Isobutyl. N-butyl, secondary butyl, isobutyl. Isobutyl. N-butyl, secondary butyl. 4, 1, 2, 3, 4 carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. N-butyl, secondary butyl, isobutyl. So what about the tertiary butyl? So see, tertiary butyl is a very simple. So this is called the tertiary butyl. This is tertiary butyl. Tertiary butyl. So these are the common examples of alkyl groups. Common. Okay. So tomorrow we will see other topics. Thank you very much. Please subscribe my channel. Thank you.